other stuff to look at now. And I want, because I hit you with a lot. Actually, I hit you with the same three things over and over again. But I want to make sure, let's shut you down. You can't see it yet. Let's shut you down. Don't save. Save if you want to. Let's scroll ahead. What I want to do now is I want to get your take on which measure you would use if you had to describe, and don't draw these, please, friends. There's text that goes with each one, and you're going to have the PowerPoint, of course. You'll have the notes afterwards. Here's a sample of 100 American men's LDL levels. LDL is cholesterol, which kind? The bad, the low-density lipid cholesterol, the one you want to have a low value of. HDL is the good cholesterol, that's what you want a high value of. So here's a sample of 100 randomly selected American men and their LDL levels. If you had to summarize this data using one number and one number only, the mean, the median, or the mode, which one would you use to summarize? I'm going to preface this by saying there is no one correct answer, so long as you can say, I think this is a good answer, and here's why. So, let's hear it. What do you think? What do you think? Carly, go!
Cool. I mean, just to play it safe, you could say mode because that's most. So you
Love
could
it.
say, like, well, most men from this survey, at least.
There's a spike. Well, can I phrase it a slightly different way?
Yeah.
The most frequently occurring LDL level was 5. And the reason I say it that way, Carly, is not a little bit nitpicky. The way you said it the first time, most men had this LDL. Technically speaking, 32 of 100 had that. That's not most, that's the plurality, not the majority.
Okay.
I hate to sound like a politician. So
No,
it's the most common LDL level based on how they grouped it. Love that. So the mode would be legit. I like that. Anybody say median? Nobody picks median? So everybody following why the mode is about 5? Right, it's 4.75 to 5.25. Perfect example of what you're talking about before with the decimals. Right? So 5's in the middle. What would the median be? Ballpark it. Don't actually get in there and you can if you want to. Wouldn't it be 5-ish as well? I mean, essentially, you're looking at what is that shape? Ish. Is ish a bell curve? Yeah, it's not perfect. But don't worry about perfect. We don't like perfect in statistics. Perfect is what Harrison Ford in The Fugitive was running away from. That's why that guy with the one arm was trying to kill him. Because the data was too perfect. And we know the data can't be perfect, so anyway. So the median is essentially going to be what, 2? It's going to be 5 as well. What would the average be?
About 5.
Good. Now, this one's trickier. Without actually calculating, it's a little bit trickier. So here's another way to think of an average. When you have a graphical display of data like this, think of where you'd have to put your finger to balance it if it were like a plate of cookies or a plate of drinks. Not a plate of cookies, you shouldn't stack drinks, I guess. So if that were like a plate of cookies that you were carrying at a party, and you wanted to show off with one finger, where would you place your finger to balance the tray? Tell me where to stop.
Directly in the center.
Define center.
Right there.
So very good. Oh, I like this very much. Yes. Now some people might get into a fist fight about how far left or right of this bar, but I guarantee most of you would pick this bar to balance it. Yes? Good. That's a way of a balance point for average. It's a way of balancing where the center point's going to be. Good. No, wait a minute, damn it. Carly said the mode is 5. She would use that. We agreed the median was 5. And what's the average?
About 5.
Arguably 5. So does it matter what we use? No. Excuse me. So basically, here's the takeaway from that. If your data ends up being what's called symmetric and unimodal, make sure you understand what those terms mean. Symmetric means, this is a Math 111 throwback, Math 95 throwback, I apologize. What does symmetric mean? Same on both sides. It could be what in half? Split it in half. I was thinking fold it. I love split though, Cass. That's good. You can fold that bad boy or split it in half and you'd have 2 equal halves. You could place a mirror right in the middle and the reflection would look like the other side. I just saw this recently. Somebody sent me a link. They took celebrities' faces. You saw this maybe? They took a picture of the celebrity's face and then they took it in Photoshop and did their face as if the left side was mirrored to both sides and if the right side was mirrored to both sides to show the symmetry of the human face. It was actually kind of cool. Some of them look kind of freaky, but most of them look totally fine. Both left and right symmetries look almost identical to their overall face. I know mine wouldn't. I had Bell's palsy from Lyme disease, so my left side's a little lazier than my right. So. Fair? So your pick. Honestly, it doesn't matter because essentially they're the same thing. They're essentially the same thing. There's absolutely no difference in the computations. So when you have, and this is why I want to get us in the habit of always looking at data. I want to always take a look at the data to see if we should use one or the other, or if it doesn't matter, like it doesn't matter in this case. Here's some new data.
What's unimodal?
Oh, unimodal, good, thank you. Sorry, Haley. What is unimodal data?
There's one mode.
Good. We can deconstruct it by Latin. Uni, one, modal, a mode. So it's got one mode, arguably one mode. That guy right in the middle that Carly was, you okay, Carly? Sorry, being back.
Oh, sorry.
That Carly was, oh no, go for it. That Carly was referring to. One mode. It's terrifying for a second. So symmetric unimodal, doesn't matter to me. Pick any of them because they're all going to be close to each other anyway. We'll have a way, and when I say close, I know some of you are you're feeling kind of skeeved. You're like, you keep saying close. What the hell does close mean? We'll have measures for close soon. I promise you that. So don't just kind of roll with it now. Roll with it. We're going to start measuring closeness starting on Tuesday. I promise that. Here, there's some fun data. I have to update it. It hasn't been updated since '09, and I just updated this in 244, so I have to wait for myself to do that. But it doesn't matter, because the point is still valid, Gesundheit, even with old data. So, I've given you some data at the bottom here. Rather than having you approximate, it gets tough to approximate these statistics on data that looks like this. Would you call this symmetric? This distribution symmetric? I don't think you can find a place where you can chop it so that the left half and the right half look the same. And when it's not symmetric, we call it skewed. And we're going to have measures for how symmetric something has to be until it's symmetric enough, or how skewed something has to be until it's skewed enough. We have measures for it. But just, you guys got a gut feeling about that. It's got a tail, and it doesn't have a tail on this side. When they have mismatched tails like that, generally that's a good indicator that there's some skew going on. Okay, so what I've done down here, it's house prices. It's house prices in November of 2009, the ones that were up for sale. These are the number of houses that were between $0 and $100,000, between $100,000 and $150,000, $150 and $2, $200 and $250, $250 and $3, $3 and $350, and so forth and so on. And the numbers really aren't relevant except for the size of the bars. The graph kept going, by the way. The graph went out to something like 14 and 18 and 20, indicating millions and millions of dollars for sale for some of the houses. This is back in '09. People still pretended things were worth that much. So the tails kept going. I've shown you what I've termed the non-outlier data. The non-outlier data. Now, even though an $800,000 house seems extraordinarily extravagant, which it might be, by virtue of the data, it's not too big. It's just big enough to fit in the normal data. The unusual data were the ones down here. So I chopped those off. If you take out those exceptionally Bill Gatesy kinds of houses, and you calculate the average and the median and the mode, notice the values. The average house price is about $300,000. That's roughly where you have to put your finger to balance this tray. Notice it's not in the tallest bar because there's too much tail over here. There's too much tail over here. You've got to squeeze this way a little bit to counteract that tail that's levering over here. Fair enough? The mode clearly is the height of that bar. Has to be. Has to be. It's still the tallest bar. The median is at 275, which is this guy. Which means you go chop, 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 chop. You chop all these off, and that takes care of this and this bar. And chop, 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 chop. Okay? I'm not going to have you chop data sets like this. It gets too tedious. Okay. So here's, if you take out those wickedly expensive houses, there were no cheap outliers. There was nothing was too cheap in this data set. And there were no negative house values. Well, maybe there were. But no, not on the market anyway. Fair so far? What happens if I put the outliers back in? What happens to the statistics if I put the outliers back in? In other words, I put in the $1.4 million house, the $10 million house, the $20 million house. I put those back in. What happens to the outliers? Or what happens to the statistics? Well, the median stays the same. Now, how can the median stay the same? Does that make any sense?
It's not based on what the value of the data point is.
It's not valued on the fact that Bill Gates' house is 20 million. It doesn't matter if it's 20 million, 2 million, or 8 $1,100,000. It's the biggest data point and will be chopped off. Now granted, there's going to be a few over here we have to chop, which means the most expensive are going to chop these least expensive. But you're still going to be in this bar when you're done. Fair enough? Good. The mode, look at the mode. 175. 175. Why?
Because it's still the most houses in the parks.
Unless there was a spike over here that was above 200, we're not going to have a second mode. And if there was a spike that was 200, it wouldn't be an outlier. We'd call it a more normal data point, and then we'd have to analyze what the hell's going on. But who gets affected? Look at the average, jumps by $100,000. That's because if this was a tray of cookies, and you're balancing it very happily at 300, and they go, hey, Rule, check this out, and they throw the cookies on that far side of the tray, where's your hand have to go? It's got to move over to balance those new cookies that are now at the far side of the tray. New cookies being the expensive houses. They haven't thrown any over on this side to counterbalance that because you can't go below 0. Is that fair? Is that a fair analogy? Now, I've introduced a term here which we will revisit in your out-of-class exam. A trimmed mean. How many of you guys have been in a class where the teacher will throw out your lowest quiz? Throw out your lowest quiz, right? They ever throw out the lowest and a highest quiz? They should, statistically. Because if you toss a low, you should toss a high to find the center more truly. Courtney's like, how dare you say that? I don't do that. I basically toss your lowest with the rainy day quiz coupon. If you bomb a quiz, you can correct. Did I tell you guys about that? The rainy day? Yeah. You can correct the quiz to bring it back up to a 10. So I'm guilty of the same bad statistics there. But a trimmed mean takes the same number off of both sides, high and low. 5% trim would take the smallest 5% of data and throw it away, and the largest 5% and re-average the middle 90. Notice, $350,000. Now good, Linda's looking right back over here. She's like, wait a minute, if we take the outliers out completely, it was only $301,000. So even with a trimmed mean, those super expensive houses are still pulling the data a little bit, the average to the left. So what's the lesson here?
Outliers skew data.
Skew what part of the data?
The average.
Boom! Outliers skew. And skew affects the average, but generally doesn't affect the other two. So if you have skewed data, you want to be careful using the average. Because the average could give a misleading interpretation of what's actually going on in the data. Be careful with outliers. Be careful. And we're going to deal with outliers in this class, I promise you that. It doesn't make any sense to talk about them right now in any depth, because we have to talk about what they are. And what they are is unusual, and then you're going to ask me, Patty's going to ask me, what the hell does unusual mean? Good question. What is unusual mean? It's a loaded question right now. How would you define unusual? What would be unusually expensive house? Well, I told you it's above $800,000, yeah? Why did I pick $800,000? Good, you should know right now.
Because of the occurrence of that.
Believe it or not, that's part of it. Yes, that is part of it. Good. Because of the occurrence of that. Although there's a pretty rare occurrence of some of these in here too. But it's occurrence and distance. Both of those things play into it. So right now you shouldn't have any idea. Just keep that word in the back of your mind. Outliers pull averages. Keep that in the back of your mind. You'll be happy. You'll be happy. Fair enough? All right, here's another data set. I decided to turn this one on its head a little bit for you. I gave an exam back in the day to 63 Math 95 students. Fact. Fact number 2, the average grade was a 71. Fact number 3, the median grade was a 78. Smallest grade was no lower than 50. Maximum grade no higher than 100. Your job, sketch a histogram that roughly indicates this. I'm not expecting one correct answer. I'm expecting many, many different answers. What do you think it looked like? You can use this as a goal. So this basically wraps up everything I just said. Fill that histogram. Fill that histogram. You know what? Let's do this. You guys can sketch it in your notebook. Let me throw it on the board up here when you're done. Use that histogram. Average 71, median 78. That's the Greek letter mu. We'll talk more about him on Tuesday. That's the population average versus X bar, which is the sample. Since this was all my Math 95 students, I figured I'd call it my population. All right. If you had to draw a histogram indicating indicating what these look like. Give it a quick sketch. Give it a quick sketch in your notebook. Realizing, of course, you're going to have this PowerPoint to refer to